Hello, we are here to learn about the Staad Pro, and we'll learn about the analysis and the design of the G+5 story RCC building. Okay, so when we click on the Staad Pro icon, so this is the starting interface. You'll get it. Okay, so here if you click on the new project, then you can open the new project. And if you click on the open project, so if you have any other Staad Pro models, or if someone has sent you models, or if you have prepared some Staad Pro models earlier, so you can open it from open project. So here you can see the recent files which you worked on the Staad Pro. So now we'll start with the new project. So this window pops up. So we'll select this space. So here when we try to model the G+5 story in the Staad Pro, we need a space where we can model the structure. So we'll select the space here, and we'll give the file name. So I'll just put it as a Staad tutorials, and here you can select the location where you want to save this particular Staad profile, and here you can select the lens units of the lens and the force units. So we usually work on the meter and kilonewton. If you want to work on the foot and kilopound, you can select foot and kilopound and select next. But now in this study we'll work on the meter and kilonewton. So we'll select meter in the length unit and kilonewton in the force unit, and we'll click on the next, and you can click on the finish. Okay, so this is the main interface of the Staad Pro, as you can see here. So this is the space where we'll create the model, and we can view in the 3D view also. And this is the main toolbar, and this is the main menu, and this is the toolbars, and these are the side toolbars. We can use it. Okay. So I'll just explain before starting any project. I'll just explain few toolbars which we'll use in the project majorly. So and the remaining toolbars as and when it is required in the project, I'll explain you about those toolbars. Okay. So if you can see these yellow color tools, so these are view toolbars. Like you can select any particular view. If you want to select from any X direction view, Y direction view, or the Y direction view, so you can use these 6 toolbars, and the 3D view also. So you can select different views from this here. So this red color these tools are helpful in rotating the structure in the clockwise and anti-clockwise direction, and the upside down in all the direction. And this is the display the whole structure. We can use this. And these are magnifying lenses. So if you want to select any particular part of the structure, if you create a very huge structure in the coming series, like if you want to see only that particular node, or is only one beam, or if you want to see that, then you can select these tools. And this option is used for the 3D render. So when you create the model, when you do the beam and column, and when you apply the property to it, so you can view the structure in the 3D render view. So we can see how structure is coming up. And this tool is used to measure the distance between two nodes. If you create a node, and you can measure it from these tools. And these are property page, support page, specification page, and load page. If you click, then you can directly go to the load pages. If you click on this, you can directly go to the specification pages. If you click here, it is support page, and this is property page tool. Okay, so this is add beam. This is the beam toolbar. So if you want to create a beam or a column, so this is the toolbar if you want to select. So this is plate toolbar. If you want to add a plate in your model, then you need to select this toolbar. And this is generate mesh, insert node. If you want to insert any node in a particular beam in one particular distance, then you can use this toolbar. and this is insert opening, and this is transitional repeat. Like if you have any repetitive in the structure, if you want to copy paste this nodes, beams or something, then you can use this transitional repeat. Or if you want to do it in a circular way, then you can use this circular repeat. We'll use these commands as and when required in the structure also. This is like overview of the overview of the tools, where tools are present, how we can use it. Okay, so this is the node cursor. If you want to select the nodes, if you want to select the nodes in the model, then you have to select the node cursor and then select the nodes. This is the beam cursor. So if you want to select the beam or the column elements, then you have to go to the beam cursor here and select, and then select the respective beams and the columns which you want to select. And this is the plate cursor. If you want to select the plates, if you model the plates in a structure, and if you want to select the plates in the model, then you have to go to the plate cursor. Okay, so before in Staad Pro, the procedure of modeling the structure and analyzing is generally in this way. Firstly, we need to create the nodes here. Okay, wherever we want, at that particular position or the coordinate, we'll create according to the coordinate system. We'll create the nodes, and then when we create the nodes, then we'll join that two particular nodes using this beam command. Then we'll create the beams. After beam and column is created, we'll go to the property page. We'll assign the property. Section sizes property is nothing but the section. We'll assign the respective section sizes to the beam and the column. And then after sections, we'll go to the support page. If we will apply the support, fixed support in our condition for the foundation. And another thing is specification. Like if you want to have the release in the building, release in the beam, then we'll go to the specification page. Then we'll go to the loads page, where you will assign the different kind of loads coming onto the structure. It might be dead load, or it might be live load. It might be the earthquake load. If you want to apply the wind load also, the different kinds of loads coming onto the structure will apply in the load pages. And then we'll analyze we'll add the different load combinations according to the IS code, and then we'll analyze the building, and then if everything is under criteria, then we'll design the building and we'll get the reinforcement required. Okay, so for our study purposes, we have selected one architecture plan. Okay, so this is our architecture plan. So this is whenever we start the project, if you get any project in the future term, the architect will provide you the architecture plan without any column. They'll provide a few architect may provide the column position according to their need. So you will have it as a structural engineer. You have to review the column position and place the column in such a way that it won't be any obstruction in places. In such way, we need to see the different views, like where exactly we can place the column, how efficient we can place the column, and still have that good design and economical design in our structural design. Okay? So this is our architecture plan. So this is the veranda, this is the entrance, this is the main hall, and you can see the kitchen here. You can see the 2 bedroom and the bathrooms, and this is the staircase part where we can go to the first floor, and the plan repeats. We will keep the plan same for the upper floors also for study purpose. Okay, so after you get this architecture plan, we'll review the architecture plan, we'll decide the column position and beam position, then we'll get the column beam layout. Okay, so this is our column and beam layout. We have decided this column and beam layout. You can see there are primary beams and there are some secondary beams also. What are secondary beams? Secondary beams are not connected to column. What are primary beams? Are those beams which are connected to the column. So these are the secondary beams which are not connected to the column. These are connected to beam. Okay, for this beam, for this secondary beam, we need to release the moment at the end position. How we can release the moment, we'll see in the start when we model the structure. So this is our beam and column layout, and we can do the center line also, center line of the beam, center line of the column. So if you do the center line, then we'll get the exact node point, exact coordinates where we can model the nodes in the Staad Pro. Okay, these are the columns. We have made some 4 grids, 5 grids, and 5 grids here. So we will mark the distances in the AutoCAD so that it will be easy for us to model in the Staad Pro. So we'll start modeling using this centerline drawing. So we'll keep this point C1 column point as the 0, 0, 0. We'll go to Staad Pro and we'll create first node 0, 0, 0. We'll select the plan view from here. Okay, and we are correct. We have done the first node. The second node is at a distance of 3.5. We'll add X. You should see the direction. You should see the global axis where how it is. So this way it is X. This way it is Z, and upward is Y in Staad Pro. So we need to move along the X. So 3.5 next, 0, 0. Then this C3 column is a distance of 6 meter. So we'll add that 6 meter, and this distance is 9.3. So we'll add 9.3, 0, 0. Okay. So we have created the 4 nodes as you can see. So next nodes we have created these 4 columns now. I mean the points, the node points for these 4 columns. We'll create all the node points for all these columns, and we'll add the beams accordingly. Okay. So this grid is at a distance of 3.7 meters. So I'll add this point 3.7. X will be 0. Y will be 0. In Z direction it will be 3.7 because we are moving down. So you can see Z is downwards. So we'll go move. We'll put 3.7 in Z. Save this file as and when it shows. It is proper to save the file. Otherwise, there might be some time the Staad must stuck and you may lose that data. So it is better to save the file as and when it shows. Okay, we have created this column point now. So next will be same as this. So we can copy paste the nodes. These nodes we can copy paste here at a distance of 3.7. So what we'll do is we'll go to node cursor. We'll select these nodes. You can use this transitional repeat. We are moving in Z. So we'll click on the Z. We need only one time repetitive, so we'll write 1 at a distance of 3.7. Okay, I'll explain this geometric generation flags and the link steps later. After we do the nodes, everything, I'll explain this what are the usefulness of these things. Okay, for now you can just go for all and don't check the link steps. Okay, just write the distances. Okay, so we can see that the nodes are created here. Okay, and we have created these nodes now. So we'll create these 3. Okay, these 2 are in same distances at 2.3. So we'll go to node cursor. We'll select this. This is one way transition repeat. Another thing is you can just copy paste the thing. You can go. You can just Control C, Control V. You'll get this pop-up, and you can write the distances. What was the distance? It was 2.3 meter. So in Z direction, 2.3. Created the 2 nodes. So this point we need to add. So we know the distance. This is 2 meter. So what we can do is we can select this node, copy paste it in X direction at 2 meter. We'll confirm the distance once. So it is 2 meter. 2. Yes, okay. So next is to create this point. So we know the distance from this node is 4.4. So we'll go to Staad. We'll select the node cursor. We'll select this node. We'll copy paste it in Z direction 4.4. That's okay. So your node is created, and we left with only 3 nodes are to be created now. So this grid is at a distance of 3.9 meter. So what we'll do is we'll select this point, copy paste it inside direction at 3.9 meter. Okay. Then what we next is this one. This is at a distance of 5.4 meter. So we'll select this, copy paste in X direction 5.4. Press OK. Our best is hit this and select this node, copy paste it at a distance of 3.9. Okay, so next will be this point. So this point will measure this distance. It's 1.7 approximately. We'll select this node. We'll measure this distance also once. It's 3.859. Okay, so we'll select this, copy paste it in X direction 3.86. Yes, okay, you got the node here. So we have created all the nodes. So you can see that wherever a column is coming, we have created the nodes there. Save it. Okay, so next will be we'll add the beam now. So you can select this beam command over here, and you can see in the beam layout wherever the beam is coming. Usually the column to column beams are connected. The primary beams are usually from column to column, those are connected. So we'll connect from column to column. Make sure that you follow one pattern while adding the beam. If you're going from this way, then add all the beams in this way, and if you're going from top to bottom, go in that same direction in all the cases, so that you maintain the uniform local axis also. I'll just remove this beam. Okay, just see wherever the beam is coming, primary beams, we'll add there. Okay, this is one. Yeah, there is no coil, it is not connected to column, so we'll add this beam later. Okay, there is some slight variation in length. So what we can do is, you can go to geometry, go to add beam, go to perpendicular direction. So what happens is, even if it is not there, the node is not there, it will directly take perpendicular direction. Then delete this. Okay, so we got the node point now, proper one. We have created all the primary beams, so a few beams are left out, so we'll do that. Okay, so you can see that this beam is at a distance of 1.21. So we can select this, copy paste it in minus X direction minus 1.2. So we are going behind this, so we need to give the minus sign, so that it will create the beam in the behind position, minus 1.2. Okay, So this beam is added now. Okay, so we can use this. You can select the perpendicular beam from here also, and another shortcut is if you long press on this, you'll get this option. Keep long pressing and select the perpendicular direction. You'll select that. Okay, just select that perpendicular, add it here. So we can't add it now this way because we have followed from top to bottom. So we'll add this just for the node point, and we'll delete this beam. So we have created the node, perpendicular node. Then you can long press this again, come back to normal beam command. So you can draw properly. Okay, we have created this beam also. This beam is left out, and this beam is left out. This beam also you can do the same way. Go to perpendicular, create a node point just at the perpendicular, then delete this because we have followed from left to right. So we'll follow the same thing. Go to normal, we'll go from left to right. Okay, so we have done this thing also. Okay, so in the Staad Pro, remember that it is always from center to center. So whatever we model in the start space, for example, so whatever we model in this start space, it is always center to center. So this is not from end to end distance. This is always Staad Pro works from the center to center always. Okay, so we'll take the distance center to center also. We'll take the distance from center to center only. So this beam is at a distance of 1.93. So I'll just click on this beam, copy paste it in Z direction, 1.93. Okay, so that beam is formed over there. So we have modeled everything. We are left out with these two beams. So this center to center distance is 2.25. So I'll select this beam, I'll copy paste it in Z direction, 2.25. Click on OK. So you have the beam. So this beam is a distance of 1.2. So I'll select this, I'll copy paste it in X direction, 1.2. Okay. So we have created all the we have created all the secondary beam and the primary. So this is the beam level. This is the beam plan. Okay, this is the beam plan. Okay, now we'll add the foundation. So if you go in 3D, so this is the thing. So now what we can do is we'll go to the node point. We'll select the nodes which are column position. And we'll take it down to 1.5 meter for foundation. So this will be acting as a plinth beam in a building. So first will be the plinth beam, then the roof beams will come. So we'll take this as a plinth beam, and for foundation we'll go 1.5 meter below. Here there is a column here. So this point and this point, there is a column here, there is a column here. I think we have selected everything. So all the column position we have selected. Yeah. 3, 1, 3, yeah. So these are the column position. So what you can do is you can go to translation, repeat, go to Y direction, first step, minus 1.5. Since we are going down, go to minus 1.5. Can click on the link step. So what happens if you click on the link step is when we copy it down at 1.5 meter, so we'll create the node also here. So between these two nodes, it will be linked. The beam will be automatically created. So that is the usefulness of this link step. So you can see that nodes are created at 1.5 also, and that it is connected automatically. Two nodes are connected automatically. So that is the useful of link steps. So we have marked the foundation also. Okay, we have marked the foundation also. So okay, so what we can do is, since we created the few secondary beams, so we'll go to general, we'll go to specification. Here you can see that there are no nodes, so to display the nodes you can press shift plus K. Save it. You can see the nodes. So why we need to do this, release the beams in secondary beam, is that since this beam will act as a simply supported beam, so these are not connected to the column position, so there won't be any movement at this junction, at this place. So what happens if we don't release the secondary beam in the Staad Pro or in a software is that the software will think that it is a fixed connection, so it will create the movement here. There will be negative movement coming over here. So that movement is not there practically. So we are not creating any fixed support over there. So it will be extra movements. So the Staad Pro will design these beams with extra movements, which is not necessary. So those movements are not present only. So it will be extra reinforcement provided here. So we can avoid that mistake. We can avoid that extra reinforcement by providing the release. If you provide the release. So if you release the movements in Y and Z direction, so this beam will act as a simply supported beam, and there won't be any extra movement coming at the junction. So how we can create the releases? Go to specification page from the general. Go to beam, release My and Mz. Don't release Mx. Mx is a torsion movement. That is that torsion movement we need to design for the design of the beam, so that we can take into picture of the torsion also. We'll create for the start. Same procedure repeat for the end. Okay. So next question will be how you can identify the start and end of the beam. So when you just place the cursor on the beam, you can see that the beam is divided into green, red and blue. Yeah. So green is the part, it is the starting part of the beam, and blue is the end part of the beam. Okay, so if you click on the start, select the beam, assign to selected beams, then assign it. You can see that this is your blue color 0 mark that indicates if this beam has been this beam has been assigned a release. Same procedure, do it for end also. Since this beam is not connected to column in both ends, so we'll release at the both ends. Okay. For example, this beam is connected here. There is a column, so we won't be releasing here. We'll be releasing only where it is connected to the beam. Okay, so this must be the starting position. So we'll go to start and assign to selected beams. Okay, there is another beam. We'll assign the start to this and end to this. Okay, so this one beam will behave, this whole beam will behave as one beam. Okay, so next is this part. So here we'll assign the start and end, and then there is this, we'll assign the start and end. So this one beam is left out, so we will assign the end, start and end. Green, it shows green. Okay, then this is the starting part of the beam, so we'll select the start. That's it. Okay, if we go to the plan view, you can see that there are few round shapes, so those indicates the releases in the beam. Okay, yeah, release the beam now. So next step, go to general. Okay, so we'll create the property for this. Go to define, go to rectangle. Here wide is the depth of the beam, so we'll take it as 0.38 380 mm, and width will be 0.23 as a brick size, or normal wall thickness 0.23, and for column we'll select 0.4 mm. Okay, we'll close this. So this is for the beam and this is for the column. Select this column property, go to select, go to beams parallel to Y. So you can see that all the beams which are parallel to the Y direction will be selected. So this is one easy method. Instead of selecting selecting each beam, selecting each beam, this is one you can select easy method. So you can go to select beams parallel to Y, X, in that particular direction the beams will be selected. If you go Y, then all the beams which are parallel to the Y direction, it will be selected. So I have selected the column property, assign to selected beams, assign, yes. You can see there comes R2, that means the property R2 is assigned to these structure members. To select the beams, same procedure, you can go to select beams parallel to X, then go to select beam parallel to Z. Okay, first remember that select the property, then select the beams for which this property is applicable. Select those beams. So we'll apply to all the beams for now. Okay, selected all the beams, property is selected, assigned to selected. So R1 is applied. Okay, so if you want to see that any particular member is missing, any particular member missed to give the property, you can check that. We can go to select, we can go to by missing attributes, select by missing property. It says that no entity with missing property is found. It means that we have assigned property to all the available structure members. If you have missed any particular section, so that particular member will be highlighted. Okay, since we have applied the property also, so now we can see the 3D view. Click here, go to 3D rendered view. You can see that how the structure is coming up. You can see you will have a basic idea like how it will look. Okay, go to general again. Okay, then go to general. We have assigned the property, we have gave the specification also. Next is support. You can create the support. Before support, what we'll do is we'll replicate the structure. We'll select this floor plan. Okay, since we are since this is the plinth level, right? So what we can do is we'll create only the first floor beams and the remaining floors will replicate it after we apply the typical loads coming out of the structure, like the wall load. So if we replicate the structure with applied load, so whenever you replicate the structure, those loads will also be copied. So your work will be reduced a lot. Instead of applying to each floor, each beam, so this is the fast, this is the good way. Like you can implicate this way, use this way. First create the one typically. This works only if your building is typical. Like if you have the same flooring plan from the first floor, then this method can be used. Otherwise, you have to replicate. Otherwise, you have to model whole the G+5 story, then select the beams where the wall load is coming, or as and when it is required. Wherever the load is coming, you need to apply this. So since for the study purposes we have ours is typical case. So what we can do is we'll do only the first floor plan, and then we'll put the basic we'll put the typical loads coming onto the structure. Then we'll replicate it. So it will be easy for us. Okay. So we'll go in Y direction. We'll keep the floor height as 3 meters, and then we'll click on the links tab. Click on the links tab. Okay. So you can see that one floor has come up. So just check whether the property is assigned to this. Okay, so these columns are not, the column property is not assigned. So what we'll do is we'll select this, save it. We'll assign the column property. Okay, so thing is here few extra columns also will be connected since we use the link command. So here there is no column for us, so we'll delete those things now. We'll delete the extra columns coming. So we'll select this only first floor. We'll go to view selected objects only, then go to 3D. Now you can see that wherever you are released, there is no column, right? That is why we have released it. So you can rotate the building a little. You can select this. So there is no column here, 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 there is no column here. Okay, there is no column here. Okay, and we have deleted all the unnecessary connected links. Okay. Yes. So we can check it also. Go to select, go to beams parallel to Y, and view only this structure. There's a shortcut to this also. You can press Alt V, press again V, you can get this. So you can see that all the, okay, this column is not continuous, so we'll delete this. So now you can see all the columns are continuous from the foundation. So now it is correct properly. Okay, you can see that releases also have been copied. If we do the transfer repeats, so releases also will be copied. So that is why we'll release at the planes level, then we can come up to the first floor. Okay, so we have come up to this G+1, or this is the ground floor. Okay, we'll create the upper floor later when we apply the loads to this particular floor, because in our case it is typical case. So we'll apply the loads. What are the loads coming onto the structure, dead load and the live load? We'll apply those loads and we'll replicate the structure G+5. Okay, so for now we'll work with only a ground floor, and then after application of the load we can go to the next stage, replicate the building. Okay. So now we have created the model. Almost the modeling is completed. We applied the load also. We have applied the releases. We'll go to support now. Go to front face. Select these. Okay. Before selecting, when you go to the support page, so first we need to create the support. Create here, fixed. Okay. Add. So one support will be created. You can select the support, then select the nodes. Assign to selected nodes. So you can see that the fixed support is applied. So here our foundation will be coming. Okay. So we have applied the support also. We'll go to load definition. Okay, loads we'll discuss in the next class. So today's class will mostly deal with the modeling part. So our modeling is almost completed except the part of replicate things. Why we are not doing the G+5 complete at once? Because since in our case it is typical from the first flow. So what we can do is we can put all the loads coming here, then we can replicate this flow. Then it will be easy for us in saving our. We'll be saving our time. Okay. So we'll save the structure. Okay. So this is one way of modeling, creating the nodes and connecting the BA node to node from the beam command. And this is one way. There is there is one another way also. Typically it's not generally used, or you can use it if you're comfortable in either way. So I'll save this file. So I'll show how you can use it. There's another way. If you go to select and if you go to geometry and if you run structural wizard, so there is one window will open up now. Okay, this window. Here you can model it. Okay. So what I'll do is I'll just save this. Okay, I'll open the new file. So I'll explain the structure wizard part from taking up the new file. Okay, so you guys won't be confused here. So I'll open the new file, space. Okay, you can go to structure wizard here also, or you can go from geometry also. Okay, I'll directly go to structure wizard here. Okay, so this truss model, this truss is for the steel structure. If you want to model the trusses, you can directly go here and you can click according to your needful. So usually we follow our roof or the lattice truss. You can give the length, width, height, and the number of bays. It will be created easily. So our we are dealing with the concrete structure. We'll go to the frame models from here. Okay, we'll go to frame models. We'll go to grid frame. Double click on the grid frame. So this option will open up. So you need to know the distances. The total length of the building, the total height of the building, the total width of the building. So for example, I'll just take it as I'll take it as 20 meter itself, or I'll take it as 21 meter. 21 meter. So I'll take it as 9 meter, and this also 21 meter. Okay, so total length of the building is 21 meters. So if you look in the plan, so length and the width is 21 meter. Okay, so here you come to this position option now. So the number of bays along the length. So this is the length. Then what are the number of grids are coming to the structure where your beam is coming. So you can create here. Okay, you can choose how many number are coming, how many grids are coming. You can select here. You can type it as 7. You can type it as 7. So you can go to this option. So you can type the length. If the grids are at different lengths, then you can type each length. From grid to grid, you can type the distance and press OK. So if we will keep the tree itself here. Height, 9 meters. So how many height? I'll take it as 3, so that the 3 meter the floor, the height of the building is divided into 3 meter, 3 meter, 3 meter. Okay. So width is same. Width and length are the same. Like depending upon the grid distance between two grids, you can enter the lengths here and press OK. Then apply it. You can see the nodes are automatically created depending upon the data here given to this Staad, and the beam and columns are created. They are linked all. You can go to plan view, 3D view. Okay. So if you want to transfer this model to the Staad space, go to this transfer model option here. Click on this. So it will select the point where you want to copy that model. So if you already have the model and you want to create that one extra special element, then you can give that particular coordinate of the node, and you can give that here. Then that element will be placed exactly at that particular node. So here we'll keep it at 0, 0, 0. The structure has come up to the Staad space. If you want to view the node wise, Shift K. Can see the node. So automatically created by the data. The Staad has automatically created the grids and the beam and column part. Okay. This is another way. This method is not like there is not freedom here, but you can use it if you have like typical pay width. You can use this structure. Okay. So we'll go, if you want to model any circular beam, then you can go to geometry, run wizard, go to frame model. There's option of circular beam, double click on it, give the radius, like what are the radius you want, you can give it. I'll take it as 8 meters. Okay. Then give the angle as 360 degrees. Since we want the whole circle, you can give the angle as 360 degree. Then this is the number of bays along the periphery. It's asking like in how many divisions you want the circle to be divided. You can take it as 18, 20 degree. Take it as 20 or something. Apply. So you can see that the circle is created with 20 divisions in it. So you can transfer this point. Go to reference point. You can select this. Okay. And select here. You can see that the circular beam is placed over there. Wherever you select, you can do that. Or if you know the coordinate of this node, you can enter the coordinates. Then it will be directly placed instead of selecting the reference. Okay. And another modeling one is, if you want to model any like cylindrical thing, so you can choose this reverse cylindrical. You can give the total length of the cylinder. Usually if you model the water tank or something, this command is useful over here. So I can go to length as 20 meters, same way, keep the radius as 5 meters for now. So we want the 360 degrees over this thing. So depending upon the length, you can type it here, apply it. So you can see that a cylindrical model is created. So if you want to transfer this cylindrical to any particular node, you can go to transfer models. That's okay. You can enter the particular node value here, or you can go to reference point, choose the point in the structure where you want that to place. So I'll take this reference point. So this, at this point, this node, it will be placed. Okay. So I'll go and I'll select the model at this. Nodes are equal, so you can see that how the reference point works. Okay. So this is another way of modeling the modeling the structure in the Staad Pro. So you can use this option if you require to model any particular structure. Okay. So today's class was basically first class was basically on the modeling, how we can model the beam, column, and assign the property specification and the support. So in the next class we'll deal about the loads, different loads coming onto the structure, and we'll assign to the failure. Okay, thank you.